Right. We just ended before the break with looking at this thing of digital transformation, where we said one thing is to use IT in your company to do the same thing more efficiently. Another thing is to actually use it to transform your organization, the products, the processes, and the business model. We already discussed briefly what happened to the media industry there, and I asked you during the break to maybe think about some other industries where you see this happening right now before our eyes. Are there any suggestions of industries where you see this happening? Yes, please. Banking, yes, very good example. Very good example. That was actually the example that I prepared in my slides. So that was very good. Before we dive into that, any other suggestions? Yes. Yes. Yeah. Yeah. Supermarkets. And it's interesting that you say the supermarkets, because indeed you could see, well, if we look at the caching system, you could say, well, having a self scan, having no scans. Um, if you say, well, just people instead of a cashier scanning the products, people do it themselves, you might argue that's a bit of supporting IT for your business, because basically your business model is the same. But it actually is, I mean, you see that companies within that industry are indeed trying to look for that digital transformation as well, because we already saw that example where they try to do these extremely quick deliveries, where you can even see some companies who say, well, we don't even have a regular shop anymore. We just bring it within 90 minutes to the client. So that changes the business model as well. You cannot have, it has implications on the inventory that you have, on your modus operandi. You work typically with very low wage people on a bike or in a car delivering the goods and so on. So that kind of transforms the business a little bit, although indeed, yeah, the business model is kind of similar, but you see that people are looking for transformations there. Yes. Kodak, yes, for photography, yes, it's kind of indeed they needed to transform, and you could see that some companies survived, some companies didn't survive. It's related to the media industry, but yes, indeed, you see Kodak was and Nokia. Voilà, yeah, Nokia. They even shift their focus a few times. So indeed, I didn't. I think I didn't. Well, I don't know who's first, but blah blah. Go. Sorry, BIM. Okay, okay, okay. And how do they transform their? I don't know whether you could all understand that your colleague mentioned BIM, so business information build building information modeling. Sorry, I'm not familiar with it. Explain to me. Okay, okay, okay. So they build things in 3D. Does the use of information technology really shifts their business model? Uh huh. Okay. Okay, so it's more iterative and continuously updates. Okay, that's interesting. So indeed, we see this digital transformation is happening in some clear industries and in some industries who are still looking for it. And one of the examples which you suggested, indeed, which I prepared a little bit, was like we see in the media industry, it kind of happened. In the banking industry, in the financing industry, we still see it happening before our eyes today, for different reasons. There is changed customer behavior, where nowadays, enforced by COVID, but it was already happening before that as well. You see that retail banking customers, they expect not to go to the office branch anymore. They expect to be able to do it on their laptop, on their smartphone, where they are, whenever they want, and for an increasing amount of services. It used to be the case that for a mortgage loan, you needed to go to the bank. It was like undiscussable that you would get a mortgage loan without seeing an actual person at a bank. We see in the last few years that this has changed, that now there are banks that allow you to have a mortgage loan without actually seeing them. So customer preferences are changing. We also see from a regulatory perspective that things are changing. Certain government regulations happen where banks need to be more open, they need to be more transparent, they need to offer ways for customers or for other companies to make use of that data to allow customers to say, well, the information that I have on that bank or even the payment authorities that I can give to that bank, I want to expose them, I want to give them to the disposal of another company. You see that new players are coming in. You have the big tech companies like Apple, which is introducing Apple Pay, like Google, which used to have a banking license in Europe. But you also see new companies, fintechs, small companies popping up who want to invade into this very lucrative, often financing and banking industry. And that has implications. That means that in that industry, you saw that, well, the number of branches of these banks is declining steeply. If you want to speak to a real person in a bank physically, it becomes ever more difficult because the number of branches is decreasing. And you see that, well, it's not just, we do the same, we have a banking account and now it's digital instead of physical. You can, even for the mortgage, it used to be physical, now you can do it digitally. No, you see that a lot of players are there actually changing the business model as well. N26, for instance, was a company, or is a company, is a banking company that was that offers a limited amount of services, but purely online. You see Aon, which was a banking service that said, well, we will provide you with the traditional banking services, but we will have kind of this AI flavor on top of it. We will analyze your invoices that you get, and we will maybe say, hey, maybe your electricity bill is a bit high. Maybe you can shift to another provider. Or they will say, well, be careful because you seem to be spending more than you are getting in each month. So these are some ways to optimize your savings and to optimize your expenditure. You see some really, to me at least, really strange partnerships showing up, like you saw Proximus and Belfius going together. Proximus, which is in Belgium, and a provider of telephony and television, so media provider company, and then a banking company which provides retail banking services. And you see these kind of joint ventures where they seem to join their offers together to the outside world. You see the same here, where a media company providing papers, so the daily newspapers, who is going together with an insurance company to cross sell from the papers to the insurance and vice versa. You see some nowadays you can get a goal alert on certain banking apps. So they try to make sure that if you're a football fan, that you can see the goals that recently happened of your favorite team on your banking app, which they didn't had anything to do with each other until a few years ago. Now you see that these things are merging. You see this one they tried, but they unfortunately they failed. This company Cake was created where they said, well, instead of people being of which the data is used by a lot of companies for marketing purposes and so on, we will allow people to own their data more and to actually sell it, to actually get part of the revenue that otherwise is fully taken by companies using it for marketing purposes and so on. And so what you see here is that the same thing happens. You see information technology, information systems that has already been used in that industry for optimization purposes. So, of course, the accounts are not taken anymore in a physical way. They're fully automated. You have a banking app where you can do the traditional stuff, where you can do transactions, transfers of money, where you can talk to a person via video conferencing, where you can have a mortgage and so on. And then you see that they also now are trying to change the business model. They try to team up with insurances. They try to get the AI flavor onto it, to added services, not just the same, but added services with multimedia, with stock apps where they say, well, let's have more easy stock brokerage or only brokerage of stocks. Let's make robot investments and so on. So you see that they are looking for ways to change their business model in a new way. And some of these combinations, to me at least, they're very strange. Like combining it with soccer, combining it with media provisioning, combining it with newspapers. But you see that they are looking for ways. You see that they are looking for ways to actually transform their business model, because they know that if they successfully do that, and certainly if they are the first mover of doing that, well, then they might become dominant. That's also the reason why you see that some of those big companies, they are looking for this super app. A lot of those strange things that you see, like here, the goal alert on the KBC app, well, it fits into the idea that a lot of companies, they are aware that people are using their smartphone a lot, that they are using apps, that people say we have too many apps, and they're looking for that super app. And so by combining all those things together, you see that a lot of those banking firms, they try to set steps towards that super app. And now in a lot of banks, if you have the smartphone app, you can not only do your banking, you can also book a car, you can look at the goals, you can look up documents from the government. So they try to make all kinds of combination with these apps, because they know, well, if we are successful in doing that, we might become dominant, and by doing that, we might explore the new business model that might arise in this industry. And the big difference between this banking industry and the media industry is that I think in the media industry, we now more or less know what happened. The traditional renting thing or selling thing went out, and it's now all streaming and subscription based. The banking model, we still don't know. We know that the branches are out and they will probably further decline. What will be the eventual system? That we don't know. We know that they are looking for that super app, and we know that there's a lot of competition there. There are lots of initiatives. Some of them fail, some of them are successful. So this is still an industry where it is happening before our eyes. And I find this very interesting to see. Another industry where it completely already happened is the traveling industry. Also there, you see that booking a trip has not only digitalized, it has also significantly impacted the business model. Because if I asked you how many hotel rooms is the largest worldwide hotel chain own, then you probably know that the number is, how many hotels does the biggest hotel chain in the world own? 0, indeed, because you might say booking.com or Airbnb or whatever. Today, most people book their hotel rooms either via booking.com, either via Airbnb or some of their competitors. But what we see is that not so many people directly book at the hotel premises themselves. They mostly go via platforms. That has positive effects, that has negative effects, that has made some companies change, some companies survive, and other new companies to arrive. Yeah? So that's also an interesting to see. And as an exercise for yourself at home during preparation of the exam, might be interesting that you try to apply that same framework, those two phases, the technological change and the business model change, to, for instance, that traveling industry, because that might be interesting for you to understand and to apply that idea of digital transformation to something else. Yeah. I see a question. Yes. No, you might argue indeed that it's not a hotel chain. It depends on how you define it. You might say, well, it's maybe not a hotel chain. True. What is true is that the traveling industry, at least, has gone through a digital transformation there. You might say, indeed, it's not an hotel chain, and this is just kind of a gimmick. But what you see is that the industry has fundamentally changed. You see that most people who want to travel to a certain city and they want to book a hotel, a large proportion of them will not book the hotel at the hotel premises. They will go via a platform, an aggregator or whatever. So you might discuss the idea, what is a hotel chain, yes or no, but what is clear is that the traveling industry itself, they went through a transformation, right? Last point, and again, let's make it a bit interactive. I've already said these IT projects, they can fail. And that's painful because they are critical. But my question to you is, do you have an idea of how many of those IT projects fail? And I would like you to go again to WooClap and to give me your opinion. So I have created a question: how many percent of the IT projects do you think fail? And you can choose every time in chunks of 20%. So 0, 20, 20, 40, 40, 60, 60, 80, and 80, 100. And I see that people started voting. Very well. Let's see at the outcomes. Can I hide it? Yes, voilà. Let's hide it for a time, so just not to influence each other too much. I'll wait until we have like something like 50 responses, 50, 55. And then we'll see. Give you 5 more. Let's take a look. Ooh, quite a pessimistic audience. You might think. Because actually, I mean, it's good, and nobody estimated between the 0 and the 20 and the 20 and the 40. You see that kind of the consensus goes to option 3 and 4, between 40, 60, 60, 80. And then there are some of you, 20%, who thinks, well, it's between 80 and 20. Let's take a look. In 1994, there was a study by the Chaos Group. A Chaos report by the Standish Group. And they started, again, redoing every so many years a study looking for successful projects. And they said, well, what is a successful project? A successful project is a project that's delivered within time, within budget, and providing functionality. And then you might say, well, I said pessimistic audience. Well, actually, if you look at them, they said only 9 till 16% was successful, meaning that basically the pessimistic audience you were, well, only 20% was pessimistic enough. In the sense that that study indicated, well, if you really look at successful projects, those who are on time, within specifications, within budget, only 9 till 16, not 60, 16% is successful. Almost 1/3 is cancelled. Only 42 actually achieve their planned scope, functionality, the business requirements. And almost half of it have a budget overrun of almost 100. That means your budget is 5 million and you'll pay 10 million. Yeah. Mm-hmm. Yeah. Yeah. Mm-hmm. Voila. We will come back to that in a second. Indeed. So it needs to be put in a broader perspective, and we will take a look at that in a minute. But these numbers, at least for me, when I first saw them, they were shocking. There are some nuances there to be brought. first of all, one might argue, okay, this definition of a successful project is quite harsh. I mean, according to this definition, it means that if you are 2 weeks too late, your project fails. That's maybe a bit harsh. If you go 2% over budget, is it really a failure? Well, good investment decisions, they take kind of a margin, and so there might be some flexibility. So yes, this definition is quite strict. And so yes, these figures are maybe a bit too dramatic. But nevertheless, they are very important, and they touch upon a very important point. Also, this study has been done in 1994, but it has been repeated several times, and we will dive deeper into that in session 3. It has been repeated several times, and we can see that the figures have improved a little bit, but still are quite dramatic. And so again, speaking of an inconvenient truth, I think this one can count. We put a lot of money in it. It is crucial. It is critical. And yet we see that a lot of failures are there. Yes, please. Yes. Yeah. It's more. It has improved, but it's still painful for the whole industry. And so again, I said in the beginning, well, open some newspapers and follow a little bit the news. It goes without saying that companies do not like this kind of promotion. So typically, if IT project fails, normally the outside world will not know it. Nevertheless, there are many reports on that in the media, meaning that there's still a lot of projects that fail and of whom the company cannot even hide it to the outside world, where we see that millions are invested and that sometimes, okay, that leads to a suboptimal project and sometimes it leads to the cancellation of the whole project. So this is not to be overly dramatic. This is just the case. And I think this also makes the case for you as future managers to study this thing a little bit, because apparently it has a risk involved with it. And so you should try to minimize that risk as well. So that was the inconvenient truth. If we then maybe look, before we go to the last part, maybe let's, and that aligns a little bit with your remark a few seconds ago. The Standish Group, they also went a little bit further. And again, we will go more in details in the third session, but they also looked at what factors determine the success or the failure. And I've listed here the failure factors that came out of their study. And these are as follows: incomplete or changing requirements, limited user involvement, lack of executive support, lack of technical support, poor project planning, unclear objectives, and lack of required resources. My question to you is at the bottom of these slides. Again, I found the 16% shocking. I also find this list shocking. Why? What is remarkable about this? Is there anything that catches your attention if you see that list? Yeah, I'll come in a minute with you. I'll just leave the room like for 1 minute to think or so. They come to the stage of planning. Yes. Yes, indeed. Very relevant. You also had some kind of suggestion. What was your idea? Yes. 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 There's only one where you can say technical support. That's an IT element. All the rest are related to non-technical issues. Of course, there is only one study, and there are not so many studies available there. And as we said, the definitions are a bit strict and so on. But for me, this is striking. If you ask those projects, what was basically the thing that made your project fail? A lot of non-technical things. And again, this makes the case why it is crucial for everyone within a company to understand these basics, because you might determine the success or the failure of these projects. Yes. Well, in a lot of cases, I mean, if you look at incomplete or changing requirements, that basically means what happens in projects, there is the project team and they go into the company and they ask people, tell me, what do you want? Well, what often happens is that people are not able to clearly express what they want, or they change their minds. Is that something, I mean, this is not a blaming game, but you might say, well, it might be the engineering or the IT part who basically needs to say, is it this what you want, or is it this what you want? Fair enough. But the changing requirements, if today person A says this, and today the other person says, no, we didn't want to have it the blue color, but the red color. At least, I mean, again, this is not a blaming game, but at least you could say it's not only technical. Executive support, it has been seen so many times that, I mean, if you want to get things going in a company, there's often one golden rule. Make sure that at the top you have support, because if things need to move, everyone has little budget, little time, and often they are not motivated to do certain things. The only way to get things moving is to make sure that the boss says, if you don't do this, you don't get your promotion, you're fired, or whatever. If you have executive support, and so that executive level says, listen, guys, this project is strategic, it needs to happen. Drop everything else that you have. This is our priority, make it work. Well, of course, then priorities of those people, they change. So again, it's not a blaming game, but at least it involves more than the technical side alone. And if you ask people what made this project fail, it's rarely the case that they say it was a wrong programming language. That will, I mean, you can often then choose 10 program languages, and they will often in some way allow you to develop the system. They will often say, well, it was on this version of Linux and I wanted to have another Linux version. No. The things that make a project fail or succeed are often these more non-technical things, and at least they involve also a lot of non-technical aspects. And this is general. This does not just map onto every single project, and there are some very important nuances to bring there. But I think it's important for you to realize that in a lot of cases, when you ask people why did this project fail, might, for instance, be user involvement. We see again that in a lot of cases, they talk these days about agile, and we make something iterative, and we come with prototypes, and we present it, and then we get feedback. We see that in a lot of cases, when a prototype is developed and it is presented to the users don't show up. The users don't show up, they don't provide feedback, or the person providing feedback is actually not knowledgeable or cannot make any decisions. Then it is not a technical problem, it's at least also the involvement of the management level. So that's, for me, I mean, it's crucial for you to know, and it's important to take away with it. Last part of today, I want to focus on some fundamental concepts that we will use later during the course. And we will not go into depth into technical things on technical basic concepts, first of all, because you probably already know them from earlier courses, or you have revised them during the preparatory course, or they are not really the core of this course. But what we will do is we'll look at those concepts, and we will each time do two things. We will briefly define it, but then we will look at the business value, and we will look at the role that they play in this business IT alignment issue that we saw before. This never-ending number 1/number 2 main concern of CIOs. Because if we look at information systems, and one of you asked about the difference between IT and information systems, well, information systems, they span a lot of things. They are very broad. For instance, okay, let's start at the mere bottom. In the end, you have hardware systems where everything needs to run. It's your laptop, it's your PC, it's your smartphone, it's all the servers, the screens that you see. In the end, if we're talking about hardware, we're talking about all those physical components in computer systems. Today, more or less, all of them are still digital, meaning they work on bits 0 and 1s. This is one of my favorite pictures. It's a picture that owns to the Computer History Museum in San Francisco, I believe it is. And it's a picture from 1956. It's not fully readable, but it's a device from IBM. Used to be one of the biggest computing companies in the world. Still today is a giant, but they lost a bit of their leading role. But certainly in the early days of corporate computing, enterprise computing, they were the reference. They were the biggest company. If you were in problems, well, there was this saying, nobody gets fired for hiring IBM. I mean, they were the trustworthy big guys doing these projects. And in 1956, they had this big transport which caught a lot of attention, big device, a little bit more than 1,000 kilograms, and they were transporting it from San Jose to another company in the neighborhood of San Francisco. And this was actually a hard drive thing for accounting purposes. It costed a few million, in current currencies. And it had the storage capacity of around 5 megabytes. This was a giant project, giant budget, 5 megabytes. Today, of course, we have this huge contrast where you see terabytes of data in a small SD stick, or in a small processor, you have giant computing possibilities. And so that means that, okay, we can store things, we can process things, but what we see in this domain on this hardware level, the thing to remember there is that, okay, there are lots of things to be pessimistic about in the world and even in IT, but the progress that we see here is beyond any imaginable thing. Because the value, as I said, we will always going to look at the value. The value of these hardware items are the fact that they are allowing you to store data and to process data. And we see that that has taken a giant leap. To store 5 megabytes of data, roughly 2 iPhone photos, you needed this thing 60, 70 years ago. Today, you have much more on these small devices. And the way how this was expressed, this very, an expression of a very positive thing we see in the industry was Moore's law. Moore was an engineer at Intel at that time that it was expressed, also one of the leading companies of processors. And he said, well, this giant speed, or this big speed of increasing capacity of hardware devices, we can express it in kind of a law that says that the number of components, so transistors, a thing that can store a 1 or a 0, a chip has several of those transistors. The number of components in a chip, so the number of transistors on every square millimeter, doubles every 2 years. And also from a technological point of view, that is something fundamental and something interesting to note, because normally a lot of things that they change in a linear way. Yeah? Every year you do plus 100 or plus 1,000 or whatever. Moore's law says this is not the case. And in hardware, we see an exponential growth, meaning that it doubles every time. So you start with 2, then 4, then 8, and 16, 32, 46, 64, and so on. So you see here a graph, and this graph is actually misleading if you don't take attention, because this is the logarithmic scale. Actually, in a normal linear scale, you would have this typical U form. You would have an exponential scale, because we see that these devices, they become ever more powerful, but not just in a linear way, in an exponential way. That's good news. That means that we get much more value for the same costs. It's a bit strange when we compare it with the earlier observation where we said, look, we have increasing expenditures, or even we saw this IT productivity paradox. You would think with this evolution that every 2 years you have, roughly speaking, double the capacity for the same amount of money. You would expect to see a very clear relationship between IT investments and value, because you need to invest less to get the same, or you invest the same and you get more. And it's also a bit strange if you compare it to these increasing expenditures, because you would think if this happens, if it ever becomes more efficient, then after a while, you don't need to invest so much anymore. I think based on what we've told today that you are able to explain this kind of seeming contradiction, because we've discussed the fact that IT alone is not enough, that you need other things as well, processes, people, and to implement it in a good way to make sure that it's not mismanaged and so on. But if you just contrast those two things, it's remarkable. What we also see is that the capacity not only increases, but that also the way in which data is captured and processed changes. Because it used to be only in those big hardware devices, in those big computer centers. Now we see that the storing and the processing of data on hardware is everywhere. It's called omnipresent. Omnipresent, it's everywhere and it's interconnected. Has some technical complications, but also a business value, meaning that today we are able to gather data in a much more fine-grained way. Today, people are walking around with their smartwatch, meaning that location data, biometric information, personal information, it's possible to be gathered, stored, potentially being used in the context of your business and organization. It also has more corporate implications. For instance, you can see you can allow tracking. You put devices where you can track each product in the supply chain, or you can use it for diagnostics. Some companies use IT systems to see when does my compressor need to have a maintenance, yes or no. And if we link that to the business IT alignment problem that we saw before, well, we see the gap is huge. So business management might walk in and they say, well, look, guys, we have a new strategy and we want you to increase our profitability with 12%. That's the goal. And of course, IT needs to cooperate. I mean, everyone needs to cooperate. And then the problem is, how do we align this? At the bottom of those information systems, we have hardware systems, storing, processing data, basically in ones and zeros. That gap is huge. One way to bridge that gap is not just to think in ones and zeros, but to simplify it a little bit for us and to use that hardware by making use of software. Software, basically, set of instructions that a computer program executes. So there's data coming in, there's data coming out, and in between you have some software instructions that takes the data, does certain things with that, and gives as an output, again, some data. We will not go into the details, but what you know is that these software systems, they work by means of a program language. And those program languages, they have the benefit that we don't need to talk to these computers in forms of ones and zeros. No, we can use actual words. And those words, they will in the end, they will be translated in those machine languages into bits 0 and 1s. For you, important to understand, and this is one of the few slides where you will actually see a little bit of coding lines here, is that such program languages, whatever language that you choose, whatever framework that you choose, they all are built on the same fundamentals. They work with, today I'm talking about so-called third generation languages. They all work with some kind of language-like instructions, but in a very basic way. So for instance, okay, I've taken Java here as an example. You can take Python, JavaScript, COBOL, whatever language that you want. They all use the idea of an instruction. Here, for instance, is the Java instruction to say, print on my screen the words "Hello World." In essence, all those software systems that we use today, all the enterprise software, all the apps on your smartphone and whatever, they work with these kind of instructions. Of course, they do much more than just print something. They can add things, they can multiply things, and so on, but they work on means of instructions. And more specifically, they have 3 ways of using these instructions. They can say, well, in a software program, you have one instruction and then the next instruction, and the software system just goes from top to bottom. It uses these sequences. You can make it a bit more efficient and you can say, well, I want to have the numbers 0 till 4 printed on my screen. And instead of saying print 0, print 1, print 2, 3, 4, you can make kind of what they call an iteration. So you build an instruction where you say for the numbers 0 until you're smaller than 5, so 4, print these numbers. 0, 1, 2, 3, 4, or you can also include selections which basically allows these software systems to evaluate a certain condition where they say, well, I define two numbers here, 5 and 10. If A is smaller than B, in this case, 5 is smaller than 10, we say A is smaller than B, and in other cases, we say it's equal to or larger than B. The reason for this is not that you need to be able to reproduce these instructions. The reason is that today, again, whichever framework that people are talking about, whichever language they are talking about, all those programming instructions, all these software systems, they consist out of these constructions one way or the other. It was even formally proven by Dijkstra. I don't know which year, like somewhere in the 70s, 80s, I guess, where he said, well, whatever programming language that you use, in the end, all those software programs, you can bring them back to a set of sequences, iterations, and instructions. Yeah? Just to give you an example, suppose that we have a more complex program. What they will do is they will create modules. So they will not just have sequences, they will create modules. Why? Well, in a typical app on your iPhone, you have 10,000 till 40,000 lines of code. That's already quite a lot. Print 40,000 lines, you will have a decent book. Your browser on your computer, I mean, the numbers are not public, but estimations go that the typical Chrome version has something around 5 to 6 million lines of code. And an electric car is estimated to have 100 million lines of code or more. So you have these simple things, lines of instructions, and then you can have sequences, iterations, or selections, but you still have, in some cases, millions of lines of code. That is complex, right? Suppose that something goes wrong. Good luck with finding the error. Good luck with making the project anyway, because you have hundreds of lines of code. So who is going to write that? You will not need one programmer, you will need multiple programmers, and you need to make sure that everything is aligned, because one line of code can influence the other line of code, and you need to make sure that it's one cohesive whole. And so one reason to cope with that complexity is the use of modules. And again, depending on the programming languages, they will be called procedures, methods, whatever. But this idea of modules is used a lot in order to group at least a little bit some of those instructions. And so what will happen is that they will say, well, let's make a small piece of code that allows us to calculate the sum of two numbers. So here we define a group or a module, and we say calculate sum. It takes two numbers as the input. It calculates the sum, and then it returns it back to whatever asked it to perform it. And we have here a method which allows us, or a module that allows you to print something. It takes an input, it actually does the printing, and then it stops. And what the software system would do in that case, it would start from the top. As usual, it will say, well, I define a certain number, a sum, and that number, that number depends on what we have here. We say, well, let's calculate the sum of two numbers, 5.7. It says, I have a module that is called calculate sum. I will provide that input here. I will execute my instructions, and I will return it here. So we have 5 and 7. We calculate the sum. It's 12. We have a sum which has the value 12. Then again, we're here. We go to the next instruction. We print it. We see, there is a module that handles my printing. I go to this module. I have the number going here, and there's a sum. And there's a printing which says the sum is 12. Again, I don't expect you to reproduce this line or this piece of coding. The thing to remember is that we work with very basic instructions often. We have millions of them, and in order to simplify it, we make these modules. And so in order to reduce complexity in software programs, these millions of lines of code, they are often grouped, and they have some other advantages as well. They allow you ideally to reuse pieces of software. So if you're writing millions of code, it helps if you do not need to write everything from scratch. It helps if you can reuse things that other people have already written before, or if you can put your own efforts at the disposal of other people. And it also helps in terms of evolvability, because if something goes wrong, hopefully you might see, well, my sum is calculated correctly, but something went wrong with the printing. So I know that here I don't need to look here in this part of the code, because I know that my sum has been calculated correctly. Apparently something has gone wrong with the printing, so I need to look it here. So the main idea is We have hardware, ones and zeros, too complex, so we use software, language, which is not human language, but at least it uses words. We use very basic instructions, selections, iterations, and sequences. We have too many lines of code, hundreds of thousands, millions, so then we need to group it into modules. We will again come back to that later on in part 3. And if you're very interested in how to deal with these giant amounts of code and giant software projects in some companies and how this is actually difficult to scale up, to work together with a big group of people, then Fred Brooks' Miracle Man-Month is an interesting book for you to read, optionally not required. Now, what is then the business value of those software systems? Well, those software systems, they allow you to automate things, to make it more efficient, the operations that you do in an organization. So to make it more cost efficient, less costs, to do it in a shorter time, to do it error-free. Once your code is correct, it will be executed the same time every time again. So in contrast with humans, programs do not make errors. If there is an error, it's because the humans didn't program it correctly. And they allow you to communicate over large differences. As I said, this is often not straightforward. This is very complex. Often this code looks a little bit like a spaghetti, very complex, and you need to untangle it if you want to optimize it. And therefore, it's important to know that if people start talking about software architectures, if they are about the design of the software system, they have a good reason for that. They are right. This is crucial in the good design or the good execution of a project, because this good modular structure determines whether these millions line of code, whether they are easily browsable or whether you cannot find anything in it. That makes our gap a little bit smaller. But still, if we want to increase our profitability to 12% and we need to translate it into these instructions, good luck. We're not yet there. So what we need in addition are databases. Probably you all know databases. Databases are, in essence, everything where you store a piece of information. So it might be the name of a person, address of a person, the age of a person. Examples of databases might be all personal data of your employees, might be all orders at your company, and often we use this symbol to represent a database. In reality, we see that there are some exceptions, but the large majority of databases today are called relational databases. Relational databases, they are databases that consist out of a set of tables, and they are relational. They are related to each other, so there are cross-references between those tables. We will dive deeper into that in session 6 and 8. But this is the main idea or the main reasoning behind it. You store some information, for instance, on customers. And on a customer, you might store the customer ID, first name, last name, age, and postal code. So this is what we call the columns. So these are the properties or the attributes. And hopefully in your company, you don't only have one customer, you have multiple customers. So you have different rows here, which are called the instances or the records. And in a relational database, what will happen is that you will not only have one table, you will have many tables, and those tables will be interconnected. For instance, the postal code 1000 in another table, it will become clear that the postal code 1000 corresponds with the city of Brussels. Yeah. Again, what is the business value of that? Well, it allows us to keep data, to store data, and not only store it once, it also allows it to create that data, to update the data, or even to delete that data, for instance, in the context of privacy. As we said before, the data is crucial because it serves as the input of those software instructions. Some of those instructions, they might ask a bit of information from the database, or they might, the software systems might provide output to the database, a result that we want to keep, that we want to store. I've included some examples downstairs because if people talk, for instance, about MySQL, Oracle, PostgreSQL, and so on, these are examples of enterprise level databases. What is yet another business value of this is that these relational databases can already provide useful and interesting business insights, even at that basic level. If you, for instance, have a database, a table where all your customer information is stored, and if you know that postal code 1000 corresponds with Brussels, then you could ask, for instance, for a printout of the first names and the last name of all customers living in Brussels. And that might have a business value. If you want to run a marketing campaign in Brussels, well, then it might be interesting for you as a company to know which are the people living in Brussels, because the ones living in other cities, we maybe don't want to address them in this marketing campaign. It makes our gap yet a little bit smaller, but still not sufficiently small. We need something else. Also important to know are networks. In typical IT landscapes, we have networks, which means that a computer software system, a database system, it's not working on its own. It works together with other systems, with other computers, with servers. So a computer network is basically the telecommunication, the communication between multiple systems in order to exchange information with one another in one way. There are different ways to classify them if you look into the literature on the scale, on the way how they transmit data. Different ways to do that. The biggest network that we basically have on the planet is internet. Interesting there is to know that when we talk about networks, the typical terminology is that we have a server, which is something that offers something, it serves something to the network. Can be a mail app, can be web servers, so to display pages. Certain applications can be running there. It can provide you access to a database. So you have all kinds of devices, physical or virtually, providing you with a server, and then you have clients, other computers, other devices in that network who basically request something to the server, to send a mail, to get a page, to execute something on an application, to get some data, and after that request, the server will execute it and respond to the client. What is the business value of that? Well, of course, they are again crucially in the context of organizations, because you don't want to have only isolated IT systems. In the beginning of enterprise computing, we saw that there was often a system in the accounting department, in the marketing department, in the production department, and so on, and those systems were completely separated. Those systems were called stovepipe systems. Everyone had their own system, and they were not communicating with each other. And then it might well be that the customer data that you had in the production system was different, in the manufacturing system was different than the one in the marketing system, and then you don't know which is now the correct address of this customer. Or you had useful information that was in one system, but the other system could not access it. So the value of those networks is that you can allow data sources to be exchanged internally. You can have different systems to collaborate instead of standalone. It also allows you to provide remote accessibility, so you don't have one system that needs to be able to do everything. No, you can have a web server, an application server, a database server, so you can have different services that you can then tap into that are remotely accessible. And you can also make connections not only within your company, but also between companies, so inter-organizational connections. We will dive later on into that, but for instance, a vendor management inventory allows a company to make a link with their supplier, and that supplier can then look into the inventory of your company and, for instance, come automatically with the pieces that you need because the inventory went below a certain threshold. Or electronic data interchanges, which are standards in order to exchange data in a commonly agreed upon way to do payments, to order certain products, and so on. So they're not only technical, they also have a business value. But again, if we try to make that link, we still have a lot of steps to add before we can close that gap. Next step would be, and then we come to the more non-technical part, in those information systems, we also need business processes. Business processes are basically, and there are millions of definitions out there, but the essence of them is that they are a set of sequences of steps in order to create a product or to create a service. In plain terms, is how things are done here at the company. The steps that we use to deliver our services and to create our products. They can often be very complex, spanning logistics, accounting, production, marketing, human resources. They can involve a lot of steps, a lot of selections and different paths and so on. But they explain the way how things are done in an organization. In session 7, we will have a specific session dedicated on how to visualize business processes, as this might help to explain to more technical people, look, this is the way how we are working. This is the area where we want you to automate something. And it might clarify what you precisely want from your IT system. And so here we see that in the end, okay, we have hardware, ones and zeros, too difficult to talk with, so we create software systems with tasks and data input and output. And what we basically say is that, well, these software systems, these pieces of programming software and these pieces of data, well, we should map them one way or the other on business process. We could say, well, this piece of software, this executes these 3 tasks, for instance. And this piece, this database, well, it covers a little bit the information that concerns our customer. So trying to close that gap, well, one way to do that is to look at how those business processes map to those systems, those software systems and those databases. And then this gap already becomes a little bit more doable. But there's more. At some point, one of you asked, but what's now the difference between IT systems and information systems? Well, one of the important differences is that information systems are considered as socio-technical systems. That means it's not just something technical. These technical devices, they need to work in a context. They need to be used by people and they need to be accepted by people. So that means if we're talking about an information system, we have, of course, a technology, but they need to operationalize processes. And in the end, people, they actuate those processes and they use that technology. How do people work in a company? Well, that's very difficult. Even though I will give you the tools and the means, I will give you a technique to write down in a formalistic way the business processes, you will see that in practice it remains challenging because in a lot of cases the way how organizations work is very tacit and very vague. People know it, but they will not just write it down on paper. A very well-known study is the technology acceptance model from Davis in the early years 80, but a lot of research has continued on that even still today, where, just as I said, there's a whole bunch of research on business IT alignment. There's also a whole bunch of research on the acceptance of technology, such as information technology. And Davis said, well, one way to understand whether people accept, whether people use technology or do not use technology is expressed in this technology acceptance model, where it depends on 2 main factors: the perceived usefulness. People will only use IT when they perceive it as something usable, that it will increase their job performance, or something which also has a perceived ease of use. It should not be overly complex. People should be able to use it in a way that is doable for them. And only then, so the way how you design it should make sure that it is perceived as something useful and it's perceived as something which is easy to use. And if you have those 2 design characteristics, well, then people will have an attitude towards using it, and that will also mean that the system is being used. So that means that if we want to close that gap, we should also not just visualize how those processes work, we should also look at the next level and how people are operating in those processes, how they are realizing those processes in everyday life. Then we're not yet quite there. We also need to be aware that in organizations, there's typically not one IT system, there are multiple systems. And so we need to think about our program. We need to think our set of IT systems, and we don't have one project, we have sets of projects. So often there are competing projects. Different departments, different teams within the organization all want to have their own IT projects. And we need to take into account the skills that we have, the money we can only spend each year once, the competitive pressure, what are our priorities to make sure that we remain competitive, what are the risks with each of those programs. So we should also really think about which projects are we going to execute and which projects, well, we don't have the money, we don't have the time, we don't have a sufficiently high priority for that. So on top of those people, actually we also need to think about those puzzle pieces. Which are the projects, which are the IT systems that make a difference in realizing that strategy of increasing our profitability with 12%, and which are the ones that will not make the difference. Yeah. Again, I mean, this is something that I've drawn myself. This is not a scientifically proven theory, but I want to use that to show how many steps and how many aspects come into play when you want to bridge that business IT gap. In the end, everything needs to work on these hardware platforms. And between that, there are several steps that you need to cross, several boundaries that you need to take in order to make everything work. You need to make sure that you select the right processes, that your people are willing to use your systems, that the processes are adequately supported by software and databases, and that in the end, that is translated into working hardware. The question is then how to align that. Because in the end, I mean, as a lot of software engineers would say, on PowerPoint, everything is possible. But the question is, how do you realize it in reality? In the end, it needs to work. And an arrow is easy to draw, to program, or to realize it in real life is much more difficult. On top of that, we've talked about things like digital transformation and innovation and so on. That also means that although bridging this gap, although bridging this starting point from we have this strategy of increasing our profitability, and although it's super difficult to translate that into hardware, into ones and zeros, that is already very challenging. But then we're even in an environment where that changes a lot. Maybe today we say that we want to address young customers in geographical area A, and tomorrow management might say, well, we have too much competition there, so we go to a little bit older customers in geographical area B. So if you already manage to establish this alignment between business and IT, it might be that within a few months, within a few years, the strategy needs to change, and therefore your projects need to change, your people need to change, your processes need to change, your software and your database systems need to change, and therefore also your hardware needs to change. And so this challenge of getting an alignment between your software systems and hardware systems in the end and the strategy is one thing, but to keep it up and running the whole time, to make sure that this alignment is there all the time, as was also expressed in this study of the questionnaire that I mentioned, that is yet even a more difficult challenge. That is even more difficult to obtain. What we will not do in this course, we will not focus on the lower part of this gap, and that's something that's for software engineers, for technical people. We will see a little bit about how to organize the database, but in a non-technical way. The program itself and how to write programs, it's a completely different study, a completely different program that we don't have the time to do it. What we will try to do is we will look at that upper part. We will look at project management. We will look at how you actually develop those systems, how to choose those systems, what are their characteristics, what are the implications on my strategy, and how do I make that connection? How do I make sure that I can formulate what I need in terms of processes, in terms of data, in a way that it's understandable for those more technical people who are operating at the lower bottom of this gap. Yeah. So that is the idea, that's the philosophy behind what we are going to do in the next few weeks. So to come to a conclusion, if we are talking about an information system, be aware it's broader than just the technological component. It's a combination of IT, it's hardware, the software, the processes, and the people who use it. That also means that we're talking about something which is socio-technical. We're talking about businesses, we're talking about organizations, so the IT system alone is not enough. It needs to be accepted by the people in the organization. They need to use those technologies. And if we use technology, it is in order to serve business and strategic needs. That means that this business IT alignment is of crucial importance, but on the other hand, we have seen both in that survey and through that graph that I designed, that it's grueling complex to achieve that, to to realize it. Nevertheless, let's try to be optimistic. What I will try to do, or I had already partly tried to do today, and which I will try to continue to do in the next few lessons, is to give you some key concepts, some key techniques, some basic understanding on how we can achieve that. And so I will not claim that I will be able to fully solve that for all the projects you will be involved in the future. But what the aim is to give you the means to at least make some kind of contribution and at least to have some starting points to tackle that. The paper that is associated with the lecture of today is IT Doesn't Matter for Nicholas Carr. It's a brilliant paper, if you ask me. It is a very provocative title, a provocative paper, and although it's more than 20 years old, it's still very relevant. It goes about the relevance of IT in achieving competitive advantages, and I think it's a very worthwhile read. You don't need to agree with it, but it might trigger some thinking processes, some reflections, which I think are very, very relevant. If you still want to read more, you can always come to me, or you can consult some of those books, which I'm really a fan of. I already mentioned Frederick Brooks' The Mythical Man-Month, which explains to you how difficult it is to actually realize IT projects with software engineers in the reality. You have Eric Brynjolfsson, that microeconomist that I talked about, that coined the term IT productivity paradox. Well, he had a very interesting book, The Second Machine Age, which he published in 2015, which is also a very nice read. If you want to know a little bit more about this digital revolution, digital transformation, and so on, you have Isaacson, who wrote some very famous biographies, but who also wrote an interesting work on the innovators, how innovations actually came into being in the past few decades, and the role of technical people, but also business people in that. So before I let you go, I want to ask you if there's any more questions, and you can still ask them despite the fact that we're almost done. Yes. The slides will be published and every week you will see this. Sorry? If all is well recorded, yes. Any other questions? No? Then I thank you very much for your presence here. I see you in almost 2 weeks. And yeah, thanks for your participation and attendance.